Welcome back to the Ephemeris podcast. I'm your host, Aphelion. Hopefully, y'all are having a great weekend if you're listening to this on the weekend when I release this. And if you're listening any other day of the week, then I hope you're having a good day so far. And so I had a bit of a weird thing last weekend where some of my prior commitments ended up taking a lot longer than I thought it would. So I didn't have enough time to plan for a podcast episode. So I decided I would save it for this weekend where we're going to have a 3 day weekend and I can just churn out 2 episodes. Also, something I will address before we get into the topic of today's episode is the fact that the episode that I've researched today is actually if I do it before as I discussed, it's Persian astronomy. Well, crazy. Um, but if I do that before Mayan, then the time scale becomes a little bit like distorted because Mayan cosmology comes before Persian, and Persian actually kind of comes in the middle of like Greek and Western. So what I'm gonna do is I'm going to make this episode 5, and I'm gonna make episode 4 ancient Mayan cosmology. But what I'm gonna do is I'm going to publish this episode 5, on like Sunday, May the 28th, and I'm going to publish the fourth episode on Memorial Day, the 29th, just to make sure that the episodes in number order are also somewhat in chronological order. So, yeah, all right. Hopefully that's not too much of an inconvenience. But yeah, as I promised in the last episode, I'll be covering Persian astronomy. I don't know why I have to be so vague about that, but yeah, we're covering Persian astronomy today, and so here we go. The prominent parts of Persian astronomy came after the beginning of Islam and kind of this age in the medieval times in that area known as the Islamic Golden Age. And the first thing that has to be addressed before we get into anything else is that not only was Persian astronomy influential to future civilizations, which we will get to towards the end of the episode, it was also influenced heavily by other preceding civilizations. So early interpretations of text is really where Persian astronomy began. That's kind of the foundations that they built off of and used to create some really, really good ideas. And so the astronomical discoveries that the Persians made kind of started with them building knowledge from translations of Sanskrit, Middle Persian, and Greek texts. And the first person we can point to kind of prove that this was definitely something that happened is we could point to Al-Fazari, right? And his notable work in terms of astronomy was translating scientific books into Arabic and Persian. And there's another person who was alongside Fazari in this kind of endeavor that is definitely a cool person to talk about. So his name is I think is it just Tariq? His last name is Tariq. Most of the astronomers that I'm going to refer to in this episode, I'm going to refer to by last name, and a lot of the kind of historical documents, I'm just going to refer to by their English translation because obviously, their names are very difficult, and I don't want to give myself a headache. So Tariq, let's call him by his last name. He worked to translate astronomical texts like Fazari, but he also had some ideas of his own. So let's get into that. He gave an estimate for the radius of heavenly bodies, quite a few of them. So let's talk about that. He supposedly measured the radius of the Earth to be around 3,675 miles, and that's kind of like from what he said, according to another Persian astronomer, I forget who. Uh, he, I think he was believed to have said that the radius of the Earth is 1,050 parasangs, which is like translates to 3.5 miles in modern measurements. So if you do the multiplication, then you get about 3,675 miles. And it turns out that the Earth's radius is almost 4,000 miles. So that's pretty accurate. I mean, there is an argument that it's not very accurate, but you are making that claim in the 21st century, to be fair. Like, on a deeper level, right, our ideas of accuracy and precision are influenced by the fact that we can make really good measurements and they can be very precise and accurate, right? But during that time, during like, what was it? I guess the 19th century of the current era, I know which is a jump, but um, during that time, obviously, they didn't have the kind of precision and accuracy that we can have today. So, yeah. I mean, Earth's radii was probably the only close calculation that he made. He was like super off in terms of the diameter of the moon and Mercury. He calculated those to be close to 18 or 19,000 miles, which I mean, if you were to think about the fact that like their only way to gauge like the radius of any heavenly body is just to think, well, because it is this far away and it looks this big in the sky, it should have this radius. That's kind of, I guess, the only kind of um, reasonable reasoning you can pull out when you have only those observations. So I guess you can give them, you can cut a bit of slack off of the error in calculation. But yeah, he also put all the other planets in the solar system in the 70,000 mile bucket in terms of radius, which is interesting. Interesting to say the least. But yeah, anyways, that's enough for Tariq and for that matter Fazari. All the translations that happened in 8th and 9th century current era. Some other things happened after that. But before we get into kind of more of the discoveries, there are also two more important people that influenced Persian astronomy, and that would be Ptolemy and that would be Brahmagupta, right? So let's start with Brahmagupta. He obviously came out of the era of Indian astronomers that was in the current era. It was way past the ancient Indian civilization kind of astronomy. I could make a separate episode on it, but I think we can sufficiently cover some of the more current era astronomers from India. So Brahmagupta was one of them, and he kind of, I guess you could say he was almost a disciple of Aryabhat, who was also another Indian astronomer, and he created a strong foundation of astronomical knowledge, Aryabhat, what I'm talking about, by establishing elliptical orbits of planets, Earth's axial rotation, and the stars' movement relative to Earth. Earth, he kind of developed the idea that stars move relative to Earth and not objectively. And he did a lot more stuff other than that, which I won't go into too much detail. But basically, Brahmagupta came after this, and he built on Aryabhat's ideas, and he did calculations. He made ephemerides of the movement of heavenly bodies, and this was I believe this was around the same, or actually, it was the 5th to 6th century CE, probably, that Brahmagupta was making all of his findings. And so, yeah, okay, that's that. And then we have Ptolemy, and his most famous work was the Almagest, which is probably talked about for centuries and centuries after he was gone. And basically, what was in the Almagest was like kind of the numbers behind the motion of heavenly objects, and the foundations of a geocentric model that was definitely there to stay for a while. And now that we have all of those influences that we've talked about, this is where the Persians start to create or start to make some progress. So Al-Khwarizmi, he used Indian methods for their calendrical and astronomical calculations in Zijaz, which is kind of the Persian astronomical book. And some of their content was definitely derived from Brahmagupta's work, but it is still the work of the Persians. And then we have Al-Biruni, and he also focused one of his works on interpreting the work of Brahmagupta, probably some of his calculations and what that has to do with the theory behind the workings of the universe. So then we have Al-Farghani, and his most famous work referred to Ptolemy, and Al-Tusi was also kind of under that same umbrella, taking Ptolemy's work and kind of critiquing it, right? And quite a lot of astronomers in Persia kind of focused their work on critiquing Ptolemaic astronomy. They were definitely a little bit more into the theory, from what I can tell, that is. And Actually, we should probably talk about this before we go any further. Ptolemy is pretty much, or well, yeah, we talked about how he established the geocentric model. So essentially, what the critique of the Ptolemaic astronomy or the Ptolemaic system would be like, kind of critiquing how the geocentric model works, and we'll get into that in a moment. But I think the most important thing that came out of Ptolemy's work is Al Sufi. He is definitely the most famous Persian astronomer. He wrote what is translated to the Book of Fixed Stars. The astronomical book listed 48 constellations along with celestial coordinates of each star in all of the constellations. And yeah, this is, I think, after they take kind of the influence from all of the people that we talked about above, this is where they start to make their own strides, the Persians. And firstly, they develop some exceptional astronomical instruments. I think if you don't take away anything else from Persian astronomy, you have to really give them a hand for the astronomical instruments that they made, because it was quite advanced. So the first thing that they created was celestial globes, and this could calculate the celestial coordinates of heavenly objects if you inputted your location on in its kind of meridian ring that it has. Which, I mean, if you take that explanation at face value, that sounds very, very advanced, because I feel like the effort level to find, I don't know, maybe a star like the Big Dipper on a celestial globe, from the description, presumably would be as easy as accessing a night sky map online these days, as long as you know how to read a celestial globe. So if that is the case, then it's definitely advanced. Maybe there's a little bit more nuance to the celestial globe, but what I can say is it's quite an exceptional instrument. And another one, another really, really big one, is the astrolabe. And this was first known to be used by Fasari, right? So credit is given to the Persians for astrolabes. And this was pretty much a device that could help you figure out what stars were at what height above the horizon in the night sky at the time. And I think, yeah, from the reading that I did, it was probably one of the most important astronomical instruments of the medieval age. It was used very commonly. And so, yeah, those are two very important ones. Another cool additional thing that the Persians created were mechanical calendars. And we talked about a bit of the calendrical work that was done just previously. Probably the most exceptional part of Persian astronomy, in my opinion, would be Al-Batani. And I think a lot of people as well do give him credit for the observations of the night sky that he made, because they were unmatched by other Persians and their measurements. Like, he noticed the change in the distance between the Earth and the Sun using his observations of the change in annular solar eclipses, which is, yeah, that's pretty darn good. And he calculated the duration for the Earth to orbit the Sun only 2 minutes and 22 seconds off of the accepted value today. So you really don't have an excuse for accuracy now, because that is very precise. It's pretty damn accurate if you ask me. Like, you can make a case for, the Reek being like a couple hundred miles off of the Earth's radius, but here you can barely make an argument for the accuracy of the calculation of a solar year. But anyways, with all this outside influence, Persians kind of used it in other ways as well. I talked about the Zijis. I talked about refining this geocentric and planetary model by Ptolemy, and some very, very specific things about the Ptolemaic system that they debated. They debated the idea of an epicycle, and what an epicycle is it's essentially a path of a circular object, but it's a very particular path. And the best way to imagine what an epicycle would look like is to imagine the path that the moon takes relative to the sun. So perhaps it's easier to digest that when I say that, but let's be a little bit more specific so that it's understandable for everybody. So it's kind of in their head in terms of what an epicycle is. So the moon obviously revolves around the Earth in an ellipse, but let's call it circular, just because neither the Greeks or the Persians like completely agreed on elliptical orbits at the time, right? So yeah, moon revolves around the Earth, right? But if you map that path out as Earth revolves around the sun, it's not quite a circle anymore. It'll kind of, it'll do like its own little loop de loops, if you can imagine that. And the path of the moon, when you put it in that context, is an example of an epicycle. So the Persians were essentially hung up on ideas like that. I don't think they were stuck with it, but um, they did create quite a lot of theory around the idea of an epicycle, and they also debated about eccentricity. Was it elliptical orbits or was it circular orbits? Right, that was another thing that was debated heavily during the time of the Persians. And okay, so now here's the time that we get into kind of the influence that Persians had on others, right? Because we've talked about the heavy influence at the beginning. They took a lot of these ideas, they worked on it, they were hung up on some of the ideas from outside influence, but the work that they did had quite a lot of influence. So the work of Al-Batani was mentioned frequently in the work of Copernicus. And if you know what Copernicus did, that's a huge honor, and glad that you know that. But if you don't, then we will definitely talk about Copernicus later on in the season. And Al-Batani's work was used by Kepler, Galileo, and some of the geophysical work that he did is still referred to by modern astronomers, which is pretty exceptional. I don't think we've had any work that has been cited by kind of modern scientists. So that's a first, and that's pretty significant. So another thing that I did not quite talk about, which I feel like you really have to see with your own eyes to appreciate it, it's the Tusi couple, and basically it's if you search it online, you'll get like a visual kind of GIF that shows you. I believe it's the Earth's axial rotation, kind of relative to a circle the size of the sun. I'm assuming, I forget what it is, but the Tusi couple is definitely like a visual model. Um, and it was used by Copernicus and the Byzantine Greens. I don't know how to pronounce that word just yet, and I'm quite embarrassed that I'm not able to, because if you learn history, you should be able to pronounce that. But anyways, Islamic astronomers also spread their wisdom to East Asia, namely to the Mongols and the Chinese, and their resource for observations were used by the Chinese and inspired them to make their own instruments. And so, yeah, pretty much it spread to the west, even to the east, and they had quite a lot of influence. And yeah, that really is a wrap for Persian astronomy. I think it's quite an interesting nugget of civilization that occurs in a really awkward spot in terms of the timeline for cosmology, because once you get to the period of time where the Greeks start to develop a lot of theory, I think Eastern influence and maybe even South American influence for that matter gets lost a little bit. And so I wanted to address that before we get into the complete Western perspective of the progress of cosmology and astronomy. And it's really hard and not like to avoid being too biased towards the Western perspective on astronomy, because obviously people who came around in the 19th and 20th and 21st centuries were obviously influenced, or they made some of the biggest strides in astronomy that we know today, and it was only a result of kind of a lot of the Western astronomy that was already happening before them. So you're kind of obliged to put a focus on kind of the Western ideas of astronomy if you want to look at the bigger picture in terms of how astronomy has progressed over humanity. But yeah, that's it for this episode. If you guys enjoyed listening to this episode, definitely make sure to follow me on Spotify. If you're listening on Spotify, if you're listening on YouTube, I would appreciate a subscribe, maybe even a like and share. Actually, I hate to be, I hate to sound like a YouTuber when I say that, but I do appreciate that because it probably does help me in terms of getting my content out into the algorithm. But yeah, that is it for today's episode. And until tomorrow, where we cover Mayan cosmology before we get into all the Western stuff. I will see you guys later. Peace.